Alright, good day and welcome. I'm looking at November 2015 Analytical Geometry, Grade 12 exam question. Right. So for November 2015, question 4. Diagram below, they say Q, 5 and 2 is the center of the circle. That intersects the y-axis at P, 0 and 6, and S. Tangent APB, so that there's a tangent intersects the x-axis at P. Right, so that is what's given to us. There they gave us an angle theta. Right, first question, determine the equation of the circle. So, determine the equation of the circle. Because my center is not at 0 and 0, my equation would read x minus a squared plus y minus b squared equal r squared. Q is the center, given as 5 and 2. So positive 5 becomes negative 5 when I substitute it in, and positive 2 becomes negative 2 squared r squared. We assume now from Q to P would be a radius. So if I substitute in the coordinates of P to get the value of the radius, P is x0 and y6. So there x is 0 and there y is 6. 0 minus 5 gives me 5 squared, which is 25. 6 minus 2 gives me 4 squared, which is 16. 16 plus 25 gives me 41 for r squared. So my equation reads x minus 5 squared plus y minus 2 squared equal 41. Right? So general question, when we give you that, you're either going to determine the equation of the circle or we're going to find it via completing the square. Right? Look at 4.2. Right, so the second question, calculate the coordinates of S. Right, now we know in the previous problem we solved the equation of the circle. Generally we will test whether you can use the equation of the circle to find coordinates. So I assume you can see S is on the y-axis. So on the y-axis that's referred to as a y-intercept, and y-intercept where x equals 0. The place of x, 0 minus 5 squared plus y minus 2 all squared equal 41. So 5 squared gives me 25. And yeah, if you forget the middle term, the whole sum becomes wrong. So please, I hope I get it into your head. So y times y squared. Y times negative 2 would give me negative 2y. Times 2 gives me negative 4y. Negative times negative, positive. 2 times 2, 4. And if we bring 41 across, comes negative 41. That gives me y squared minus 4y. 25 plus 4 gives me 29. 29 minus 41 gives me negative 12. Right, so y squared can only be y times y to get y squared. Factors of 12, negative 6 times 2 would give me negative 12. But minus 6y plus 2y would give me negative 4y. Therefore y equal to 6 or y equal negative 2. So y equal to 6, you should see it's given there already. So therefore S here is below on the negative y-axis. So therefore S is 0 and negative 2. Right, so basic. 4.3, determine the equation of the tangent APB in the form y equal mx plus c. Right, so first, assume you know this blue line from Q to P is my radius. The radius and the tangent will always meet at 90 degrees. So if I get the radius of QP, so gradient of QP, y2 minus y1, x2 minus x1, so that reads 6 minus 2, and then 0 minus 5. Gives me 4 over negative 5. Therefore the gradient of the tangent will be inverted or reciprocal. 5 go top, 4 comes bottom, and the sign changes. So the radius or gradient of the tangent, 5 over 4, because my tangent is always perpendicular to my radius. So there where the blue line meets the red line, they must form a 90 degree. So y equal 5 over 4x plus c. You can see the red line intersects the y-axis at 6. So I don't still need to calculate c, that is the c value, so therefore c equal plus 6. I hope you got that. So I'm not still calculating. C is always where x is 0 and y is whatever value. So y is 6 there, therefore c is 6. Right, I hope you're enjoying the lesson so far. Please like, share and subscribe. Let's look at the next one. So calculate the size of theta, right? So we want the size here. You should see there in green. My angle must always start from the x-axis until it makes contact with the line. So we have the gradient of line APB, therefore we can use angle of inclination to solve, which states that the tan of alpha would be the gradient of APB. So gradient of APB from the previous problem was 5/4. On my calculator, I'm going to press shift, tan 5/4. On some calculators, second f or second function, 5/4, and you should get alpha equal 51,34 degrees. That's testing your grade 11 angle of inclination problems. Right, let's get the next problem. Calculate with reasons the sines of theta. So they want the sides of theta. Now you see then blue I've drawn a triangle. There's my tangent. Right? We assume you remember that any angle formed between a tangent and a triangle must equal the angle directly opposite it in a triangle, in a circle. So according to tan chord, if that's theta, this angle is theta. There where the Cartesian plane meets, there's always a 90-degree angle, and we already have alpha, which is 51,34. So to get theta, angles in a triangle, be 180 minus the 90 minus the 51,34, and theta then equal 38,66 degrees. So 38,66, 38,66. SPB, as you can see there, equal theta because tan chord. So tan chord starts from the tangent till I make contact with the chord, right? That chord then must form a triangle there in blue. Therefore, they are equal according to tan chord theorem. Let's look at the next problem. Calculate the area of triangle PQS. So there's PQS. So they're in light blue. I have PQS or baby blue. I don't know, teal, whatever you'll call the color. You know, we guys are a bit colorblind. Right, they want that area. So number one, we know the equation of the circle is x minus 5 squared plus y minus 2 squared equal 41. Right? QP is a radius, QS is a radius. So QP and QS, remember that's r squared, so the radius would be square root 41. So they put square root 41. They are radii. PQS, so PQS, right, angle at center equal 2 times angle at circumference. So therefore Q there is 2 times 38,66. Gives me 77,32 degrees. My reason angle at center equal 2 times angle at circumference. Just to refresh, you see that angle R. If I go back with the blue lines, is subtended by the chord PS. If I go with QP and QS, they also subtended by PS. Therefore, angle at center must equal 2 times angle at circumference. Now for the area of that triangle, because I have two sides, I have PQ and QS and an angle in between, I'm going to use the area rule from trig in 3D. So half times PQ times QS sine the inclusive angle in between, right? So half 0,5 PQ square root 41, QS square root 41, and the angle 77,32. So my area is 20 units squared or 20 square units on the dot. So I hope you enjoyed the lesson. I hope you understand. It's just one exam question. As I said, grade 12 analytical has one grade 11 question and one grade 12 question. So I'll do the grade 12 separate and the grade 11 separate. Right, so we should